covered the section on the Pythagorean theorem. Our learning target for today is that you will be able to apply the Pythagorean theorem. So in order to do that, you need to know what it is. So years ago, a man named Pythagoras found an amazing fact about triangles. The first thing that he noticed is that the triangle had a right angle, 90 degrees. So it has to have a 90-degree angle. Okay. And you make a square on each of the three sides. Okay. So he made these squares around each of the three sides, with a length of A, a length of B, and a length of C. Okay. What he noticed is that the biggest square had the exact same area as the other two squares put together. So if this has a length of A, this side is A, so this is A times A, or A squared. This has a length of B, so this has a length of B, so B times B is B squared. And lastly, this has a length of C, and this is C, so C times C is C squared. He noticed that if you took the area of my smaller two and you added them together, okay, you would get the same area as my big square, which gave us the Pythagorean theorem. Okay, A squared plus B squared equals C squared. Biggest thing to notice about the Pythagorean theorem is that it has to be a right angle, okay, and also C has to be your hypotenuse. And like they said, it's as the longest side. So the hypotenuse is always the longest side. It's also always across from the right angle. Okay, so this would be my hypotenuse. So we're going to find the missing side of the triangle using the Pythagorean theorem, and we're going to leave our answers in simplified radical form. Okay. So leave it as 2 square root of 6, not 4.9. Okay. So if I look at example 1, I have a side length of 6, side length of 15, and a side length of x. Well, I need to know which one is my c value, or my hypotenuse. Which one is across from the right angle is my hypotenuse, so that is x. So it would be 6 squared plus 15 squared is equal to x squared. Okay. Well, this gives me 36. Plus 225 is equal to x squared. 36 plus 225 is 261 is equal to x squared. Now remembering how to solve this from last trimester, you take the square root on both sides. Remember when you take the square root, you get two answers, plus or minus. So we get x is equal to plus or minus the square root of 261. Okay. Well, I need to write it in reduced or simplified radical form. So I say, well, what's my perfect square in 261? Well, 9 times 29 gives me 261. So I can really rewrite this. 9 times 21. The square root of 9 is 3. And then square root of 21 is not a perfect square, so I would just leave it as that. And then the biggest thing to remember is, okay, well, this is the side of a triangle, so can you have a negative side length? No, you cannot. And so my only answer is that x is equal to 3 square root of 21. Okay. Example 2. Let's go ahead and look at that one. Once again, I'm going to do the Pythagorean theorem. I figure out which one is my c side or my hypotenuse. Across from that right angle, so this is my c. So I would have 17 squared plus 7 squared is equal to x squared. 17 squared is 289 plus 7 squared is 49 is equal to x squared. 289 plus 49 gives me 338. And once again, I would take the square root on both sides. So I have plus or minus the square root of 338 is equal to x. And now I say 338. What's my perfect square that divides 338? Well, 169 times 2 gives me 338. So I can write this as x is equal to, it's plus or minus, but once again it's a side length, so I only want the positive side, the square root of 169 times 2. And the square root of 169 is 13, and the square root of 2. So my answer is 13 square root of 2 for example 2. Now let's go ahead and look at example 3. I look at this one, once again, right away, find my hypotenuse. I see across from my right angle is a side length of 11, so that is my C. So in this case, I have x squared plus 9 squared is equal to 11 squared. X squared plus 81 is equal to 121. Then I would go ahead, I need to solve for x squared, so I would subtract 81 from both sides. I would have x squared is equal to 121 minus 81 is 40. Now from here, I would need to go ahead and take the square root. So I have that x is equal to plus or minus the square root of 40. So I would say, well, what's my perfect square in 40? 4 times 10. 4 is a perfect square. So once again, I only want the positive because it's a side length. So 4 times 10. And the square root of 4 is 2. The square root of 10 is not a perfect square, so x is equal to 2 square root of 10. Okay. Now would be a good time for you to take a pause, take a break, write down any questions that you may have, and you can ask them to me tomorrow in class. But feel free to pause the video before we go ahead and move on. Number 4. Damon is locked out of his house with the only open window on the second floor, 12 feet above the ground. Okay, so I look at my picture, 12 feet above the ground. They have it labeled for us. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet away from the house to avoid some shrubs, what length of the ladder does Damien need? So he needs to be 5 feet away so he doesn't hit any shrubs. So I would look at this and I would see that, well, this right here is a right angle. Okay, so if this is a right angle, the ladder is my hypotenuse or my C value. And we don't know what that is, and we need to know what that is. So I would have 12 squared plus 5 squared is equal to x squared. 12 squared is 144 plus 5 squared is 25 is equal to x squared. 144 plus 25 is 169. And then once again, I would take the square root, getting my plus or minus 169. Okay, the square root of 169 is 13. But once again, do I want a negative ladder length? No, so x is equal to 13, and I would label it feet. Common Pythagorean triples, okay? You don't need to memorize these, however, it might be helpful. So what a Pythagorean triple is that if I plug it into the Pythagorean theorem, so for this case, this example of this triangle here, I would have 3 squared plus 4 squared. Does that equal 5 squared? Okay, well, this is 9 plus 16. 25 is equal to 25. So what it is it's essentially just saying that they are perfect numbers. If you guys notice, the first 3 examples would be irrational. They will go on forever. These are, if I solve it, I get an integer value. Example 4 would be an example of a Pythagorean triple. It'd be a 5, 12, 13 triangle, which is written right here. Okay. So here's a few examples of Pythagorean triples. One thing to know is that any multiple of any of these is also a Pythagorean triple. So if I were to go ahead and multiply everything by 2 here, I would have a 6, 8, 10. That would also be a Pythagorean triple. If I plugged it in to my formula, it would all work out nicely. If I multiplied each number by 10, I would get 30, 40, 50. That would also be a Pythagorean triple. Essentially, if I take any number, n, times each one of these values, 3, 4, and 5, I will get a new Pythagorean triple. So there's multiple options for Pythagorean triples. Same thing for the other one, the 5, 12, 13. If I multiply each one by 10, I would have 10, 24, 26. That's one example. If I multiply each one by 10, 50, 120, 130, that's also a Pythagorean triple. And essentially, I can multiply anything by n, and I will get another Pythagorean triple. Okay, so if n is 2, I will get that example if n is equal to 2. Plug in 2 for n and you get each one. And lastly, my other one I want to talk about is 7, 24, 25. So same idea. If I multiply each one by 2, those are a Pythagorean triple. I can multiply them by 10. That'd be a Pythagorean triple. I can multiply by 100. That'd be a Pythagorean triple. So whatever n is, I can multiply by. So that will get me a new set of Pythagorean triples. Okay. So here's some examples that we're going to go ahead and work through. 5, find the value of x. Okay. It gets a little confusing because there's two triangles in here. But if you look, I have my hypotenuse because it's across from my right triangle. I have a leg because it's 10, and then I have another leg because it's x. So in order to set this one up, I would have 10 squared plus x squared is equal to 14 squared. 10 squared is 100 plus x squared is equal to 196. 14 squared is 196. I would subtract 100 to the other side. So x squared is equal to 96. And then I would go ahead and take the square root. X is equal to the square root of 96. And then I would say to myself, well, 96. What's my perfect square that multiplies to 96? Well, 16 is a perfect square. 16 times 6 gives me 96. So x is equal to the square root of 16 times 6. The square root of 16 is 4. Square root of 6, we would just leave as the square root of 6. So x is equal to 4 square root of 6. That is my simplified radical form. Then if I go ahead and look at example 6, find the value of x. Now this one looks a little tricky, but it's actually not too bad. Biggest thing to note is my hypotenuse is x plus 1. So I would start with my legs. So I would have x squared plus my other leg is the square root of 2 squared is equal to x plus 1 squared. Well, I would leave x squared as x squared plus the square root of 2 squared. Well, we all know that the square root and the square will cancel each other out. So I'm left with 2 is equal to x plus 1 squared. I need to simplify my right-hand side, and I know that x plus 1 times x plus 1 is the same as x plus 1 squared. So I would FOIL that right-hand side, and I would get x squared plus x plus 1. And then I would go ahead and combine my like terms on my right-hand side, so I'd have x squared plus 2x plus 1. I would notice if I subtract x squared from both sides, I have 2 is equal to 2x plus 1. I would then subtract 1 from each side, noticing that this is linear. So I have 1 is equal to 2x. And then I would go ahead and divide both sides by 2. So 1/2 is equal to x. Okay, and we had to just find the value of x for number 6. So x is equal to 1/2. And our last problem for today, we are going to go ahead and look at number 7. And number 7 tells us once again to find the value of x. And the problem looks like this. Tells me this is a right angle. We need to find x. Well, my right angle is here, so across from it's my hypotenuse, so my hypotenuse is x. So remember that's your c value. So I would have 9 squared plus 12 squared is equal to x squared. 9 squared is 81. 12 squared is 144 is equal to x squared. 81 plus 144 is 225, and maybe some of you already noticed this would be a Pythagorean triple before we started. And so I would take the square root on both sides. And so x is equal to, well, the square root of 225 is 15. So that is my value of x. So notice it's Pythagorean triple because my sides are 9, 12, 15. Okay. and that would be a multiple of our 3, 4, 5 Pythagorean triple. And the way that you would get there is just multiplying this by 3. Okay, so it was just an example of another Pythagorean triple as well. So the next thing that you're going to go ahead and do will be the Pythagorean theorem worksheet. Please make sure you write down any questions that you have so you can ask me in class, and I will see you then. Have a good day.